Hello and welcome everyone. I'm your instructor, Dr. Choi. Today's topic is summarization of different types of studies and level of evidence. So far, we studied descriptive and analytic study and observational and experimental study. And we also discussed correlation and causation. Only experimental study can claim causation. And prospective study and retrospective study and case control study and cohort study. And these can be confusing, prospective and retrospective and case control and cohort study. And let's quickly review what we did so far. So descriptive and analytic, how do you differentiate it? And what is the importance of these two? The importance of analytic study lies on existence of control group. If there is no control group, it is just literal description of what happened with your topic. So with a descriptive study, you cannot claim correlation. Correlation means the relation between A and B. So A and B means control group. And second, we studied observational study and experimental study. Observational study can have control group or not. Both are possible. Experimental study always have a control group. Experimental study need a control group, and the key difference between these two studies is playing God in assigning two groups. So experimental groups and control groups, how they are divided by forceful intervention. So that is the reason I say playing God. So when you're assigning those two groups, if you play God, there is an experimental study. You need to force someone to stay here and someone to go there. So when you roll the dice, if there's an odd number, you should go there. And if there's an even number, you should go here. So that kind of assignment is experimental study. These days, only randomized assignment is considered as an experiment. So it is getting strict and harsher and tough to define experimental study. On the other hand, observational study, even though they have a control group, nobody force subject to do something or not. So they just do whatever they want to by their nature or their favor. Nature or favor. So it is just nature. So that is the reason we say observational study, because researchers just observed what happened. And next, prospective and retrospective. It's kind of straightforward. Prospective means study goes on from now on to the future. And retrospective means you already have a data. Something already happened. So you collect those data and analyze data, and you get the result. That is a retrospective study. It is very straightforward. Only thing you need to consider for differentiation of these two is when these things happened. When these things happened. So if it happened before you start the study, that is retrospective study. If you do not have any consequence when you plan the study, that is prospective study. Something really confusing is case control study and cohort study. It seems like just another description about prospective study and retrospective study, but it is not. Case control study starts from outcome, already happened outcome, and to the exposure, meaning what caused this outcome. So when you study lung cancer, you backtrace if they smoked or not. There is case control study. So all the case control study is retrospective study. Cohort study are exactly opposite. It starts from exposure to outcome, so consequence. So you do not have consequence yet. So smoking or non-smoking, you have those two groups. In other words, we say cohort. So smoking group and non-smoking group, and compare how many people got lung cancer. That is cohort study. So basically cohort study is supposed to be prospective study. But there is very odd study form that is called retrospective cohort study. In that case, you have all the data already and backtraced all those old data. So you start from smoking and non-smoking based on data, and you trace how many people got lung cancer or not. That is retrospective cohort study. But if you have a trouble understanding retrospective cohort study, that is okay. Retrospective cohort study, usually they clarify if it is a retrospective cohort or not. And even though the name has cohort in its title, but evidence level is very low. So almost similar to case control study. So only prospective cohort study considered as a strong evidence. This is what we did till the last week. Today, let's summarize it with this tree structure. So epidemiological studies can be divided into descriptive study first and analytic study. In descriptive study, there is case reporting series. In analytic study, meaning has a control group, experimental study, and observational study. You can divide them in a different sequence. First, experimental study and observational study. In observational study, there are descriptive studies and analytic studies. So this cohort study is analytic and observational. And case control study, same. Analytic and observational, because they have a control group, but nobody forcefully assigned the group. That makes observational study. Experiment study and cohort study and case control study, all of them have a control group. But when you divide the groups forcefully by randomization, it is called experimental study. So if you just understand this tree structure, you can analyze all the studies based on this concept, the properties. So these are the key points. Case studies are observational and descriptive study. Case studies, observational, and also descriptive. Cohort and case control studies are observational and analytic studies. Experimental studies cannot be either retrospective or descriptive study. Experimental studies such as clinical trials are always prospective and analytic study because it has control group. And these studies involves randomization and control groups. Therefore, studies without randomization, like before and after studies, are not considered experimental studies. Please underline this. Same tree structure in different association and institutions. So I made it a little bit simpler. So this table diagram starts from descriptive and analytic. In analytic, experimental study and observational study. On the other hand, this diagram starts from experimental and observational. Can you see? Only the sequence is different. In observational study, there are randomized control trial, non-randomized control trial. But either way, both groups are divided by force. So forceful intervention in assigning the two groups, control group and experimental group. Observational study, analytic study, and descriptive study. In analytic study, case control study, cohort study. Cross-sectional study, this is something I didn't explain. This one has no time attribution. So like a survey, election survey is cross-sectional study. It doesn't have time attribution. But in the clinical medicine, it's very hard to find this type of study. It is commonly used in epidemiologic studies or social science studies, but not in clinical studies. So this is the final algorithm. So when you solve those questions in the midterm test and final test, you gotta use this flowchart. If you fully understand only this flowchart, I guarantee you can solve all the questions in the final test.
The algorithm starts by asking if the study has a comparison group. If no, it is classified as a descriptive study. If yes, it asks whether the comparison group was assigned by force. If no, it is an observational analytic study. If yes, it is an RCT experimental study. For observational analytic studies, it further asks if the analysis started from the cause. If yes, it is a cohort study. If no, it is a case control study.
So but only be careful with this one. If they start from exposure cause, that is cost study. If they start from outcome, that is case control study. So there are some examples here. Take a look at this. 100 patient with hypertension and 100 patient without hypertension. What does that mean? Already we have an outcome, consequence, hypertension. And we want to find out what causes hypertension. And we investigate what kind of exposure made the difference. So this is the sequence from outcome to the exposure. If you want to make this one as a cohort study, you need to start from acupuncture or not. So you first define someone who get acupuncture regularly and someone who doesn't get acupuncture regularly, which means there is a cause, exposure to acupuncture. And later, in 5 years, you compare how many people got hypertension. That makes cohort study. So let's go back to the diagram here. So if it started from the cause exposure, there's a cohort study. If they already have hypertension or not, that makes case control study. Okay, let's try some examples. First example.
To investigate the relationship between smoking and lung cancer, 10,000 healthy adults are recruited and divided into two groups based on their smoking status. One group consists of 5,000 smokers, and the other group consists of 5,000 non-smokers. Both groups are then followed for 10 years to monitor the incidence of lung cancer.
So what is the research question of this study? Correlation between smoking and lung cancer. And what kind of study it is? Let's find out with this flow chart. Does it have a comparison group? Does it have a comparison group? Divided into two groups based on their smoking status. So one group, smokers, another group, non-smokers. Obviously, it has a comparison group. So this is an analytic study. And second question, is this comparison group assigned by force? So what does that mean? Did the researcher force someone to smoke and not to smoke? No, they didn't. It's totally decided by their favor, what they have been doing. So this is observational study. So you didn't play God in this case. And the last question, did an observational analytic study, this study started from cause or outcome or consequence? So what is the cause and consequence? This is cause, smoking or non-smoking. Lung cancer or not, this is a consequence or outcome. So where did the study started? From smokers and non-smokers. And they compared how many people got lung cancer or not. So it starts from cause, smoking or non-smoking, cause and outcome. So is this study started from cause? Yes. So cohort study. This is cohort study. Is it prospective or retrospective? Followed for 10 years. So researchers didn't have any data. How many people will get lung cancer or not? And they are getting data in 10 years. So this is prospective study. So this is prospective cohort study. And let's see the second example. So let's take a look at this table, the diagram flow chart.
To investigate the relationship between smoking and lung cancer, 500 patients diagnosed with lung cancer in the past year are selected as the case group. An additional 500 individuals without lung cancer, matched by age and gender are chosen as the control group. Data on smoking history and other relevant factors are collected from both groups through interviews and surveys. The prevalence of smoking history between the case and control groups is compared to determine if there is a significant association between smoking and the risk of lung cancer.
Yeah, think about it. What is the research question? Research question is same with the last study. Correlation between smoking and lung cancer. What is the cause, exposure, and what is the consequence, outcome? Smoking is cause and exposure, and lung cancer is the outcome. So let's try to figure out what kind of study it is, step by step. Does it have a comparison group? Does it? 500 patients diagnosed with lung cancer and additional 500 individuals without lung cancer. So this study has a comparison group. And these two groups were assigned by force, somebody decided who get lung cancer or not, researchers, external forces. No, they just got a lung cancer based on their living. So it is just nature decided. So is the comparison group assigned by force? Answer is no. So this is observational and analytic study. And the last question, did this study start analysis from cause? Let's see, what is the cause? Smoking and lung cancer is a consequence. But this study already have the patient who have lung cancer and or not. So lung cancer is a case and without cancer is a control group. So this is case control study. So it didn't start from the cause. Actually, it started from outcome, consequence. So is it retrospective study or prospective study? So data on smoking history and other relevant factors are collected from both groups. Interviews and surveys, meaning they backtrace the past data. So this is a retrospective study. So all the case control study are retrospective study. So case control study. Now why we are doing this? Because of level of evidence. And I will talk more in detail about this level of evidence when we talk about EBM. And there are a couple of tables, different tables, but there's something in common. Randomized controlled trial is in a top hierarchy in terms of evidence. And cohort study and case control study follow that. And case report and case series, those are the least powerful evidence. And this is actually suggested by Dr. Sackett a long time ago in 70s. And nowadays, this table changed in many different ways. So there are many different level of hierarchy tables and diagrams. In this class, I'll use this table. And this table is adopted from Oxford, UK level of evidence. So this one, I simplified this table. So on the top hierarchy, there is a systematic review of a randomized controlled trial, but we didn't discuss about systematic review yet. And second, randomized controlled trial. So in our class, this is the most powerful evidence. And third, individual cohort study. And fourth, case control study, right next cohort study, and before and after study, and retrospective cohort study fall into this category. The fourth, powerful evidence. And fifth powerful evidence is case series and case report. So by discerning the type of study, you can tell the level of evidence. So final term testing will be all about this, discerning the type of study and figuring out the level of evidence. So we got to do a lot of practice with the actual studies and hypothetical studies. One more study we didn't discuss so far is systematic review. Systematic review is one of the review study, and there are many different kind of review studies. So let's talk about many different types of review studies, especially focusing on systematic review. Please watch this video clip, and we will take a break, 10 minutes break, and we will start practice drill. Review study is the literally review of original studies. So I have an analogy with the review study. It's like dishes with fish and veggies, and actually based on its ingredients we can divide review study into two categories. First one is analytic review and descriptive review. So analytic review is the review of analytic studies. So this is the review study analyzing the analytic studies like RCT or cohort studies or case control studies. So the ingredients like a fish and veggies, they are all analytic studies. The review of those studies make this review analytic review. So we call that analytic review. On the other hand, descriptive review is based on the studies, descriptive studies, based on descriptive studies. So we call that descriptive review. So both of them have a different purposes. So analytic review is aiming for validating the effectiveness or efficacy, while descriptive review is aiming for the conveying the information. So here is the example. Like a meta-analysis, this is analytic review, and this style can be easily seen in PubMed or any other search engines. Physiological effects of acupuncture. So you can see what kind of physiological effect acupuncture has. So this is quite informational. And the other property of the review study, so these are all review study, and this is the different category based on how they cooked, so how they searched it to review. So you can select the ingredient based on your favor. Maybe to prove your point, prove your statement, you need some evidence, like formal studies, which can support your statement. So based on your favor, you can select those studies and you can claim or you can insist maybe one of your hypotheses. That is the narrative review, non-systematic review. Usually we call that narrative review. So author reviews various sources based on author's decision. If the author think those articles are important, author write a review based on those studies. So for example, future of the acupuncture, maybe the future of the acupuncture. This is quite something like an opinion, and to explain the future of the opinion, you can collect a bunch of studies, including other opinions or in vitro studies or in vivo studies. Based on those studies, you can state what you think about the future of the acupuncture. So that is a narrative review. You don't have to be systematic, claiming the future of the acupuncture. And systematic review is quite popular type of study in these days. First, let's check the definition. Simply, we can say this way: source studies are chosen, so ingredients are chosen for this dish for cooking in systematic way. So I can say fair and square way. So you are not excluding something because you don't like or because you do not think that is not important, but you exclude something or you include something based on very clear standard. So let's say this: definition and CDC website. So systematic review attempts to collect and analyze all evidence that answers a specific question, research question. The question must be clearly defined and have inclusion and exclusion criteria to examine that hypothesis. So as long as the review study has clear research topic and clear exclusion and exclusion criteria supporting the research topic, and to answer the research topic, we can call that systematic review. But most of the clinicians think in different way. So here's a narrow definition, and this is the evidence hierarchy of the evidence. And systematic reviewing is located at the top of this pyramid. This is not systematic review, which is located at the top of the evidence pyramid. And this is the type of the systematic review we usually think when we refer to systematic review. This is the definition from Cochrane organization. Let's see. Systematic review summarizes the results of the available carefully designed healthcare studies, usually controlled trials, and provides a high level of evidence on effectiveness of the healthcare intervention. So mostly this study is the study for validating the effectiveness of the intervention or validation of diagnostic tools, like a certain new type of tomography or new type of the physical examination, or the effectiveness of acupuncture or herbal supplement. So when you want to claim certain intervention is effective on a certain condition, we need first RCTs, the controlled trials. And based on controlled trials, you can write the systematic review. That is usually called systematic review among clinicians, and this systematic review is located at the top of this pyramid. So there's a slight difference between these two, the general definition and narrow definition. And this is the table differentiating systematic review and narrative review, and this is the main difference. Describe and appraise the published articles, but method used to select articles may not be described, clearly notified beforehand. So this is the characteristic of narrative review. And on the other hand, systematic review, the query is well-defined review question and secondary question, and clearly defined the criteria for selection of articles. So those are the difference, and you can read the rest of the table. And we can clearly see this concept, the classification, the property of the review studies. Let's try to understand different type of review studies with the examples. So here quadrant. This is the first properties of the review study, first narrative and systematic. And this differentiation, this categorization is based on search method. This is the random search and this is the systematic search. And second property is descriptive or analytic. So this is called descriptive review and this is called analytic review. And descriptive review is based on studies which is descriptive. So review of the descriptive studies, and this is the review of analytic studies. So there are the studies, descriptive and narrative. That is just random search by the author's favor, by the author's decision, and sources without comparison. So any sources, not only the RCTs. So this is the top. This is the study. We can call descriptive and narrative. Maybe the same word. So this is very descriptive. So acupuncture is all placebo, and here is why. And he is cooking the dish, which is called acupuncture is all placebo, based on researches, studies, formal studies, which he choose on his own decision, maybe she, Brian, maybe he. And the result of this study conclusion, practitioners need to do a better job of discerning truth from the information and data available on acupuncture. This conclusion should not be used as evidence of something, but it can be his opinion. That is the purpose of the descriptive study and narrative study. And second, there can be narrative, but not systematic, but analytic study. In this case, the resources, the ingredient of the dish, are analytic studies. So let's see this example. So title, Acupuncture in Pediatrics. So it seems like the author tried to clarify the effectiveness of the acupuncture in pediatric problems. So if you see this abstract, you can read the randomized controlled trial and RCTs. Maybe you think this is a systematic review in narrow definition, but if you read the full text, you can see these articles inside in this review. So ingredient articles, resource articles are not chosen in systematic way. So first of all, this article and this review is taking care of in various diseases. Besides asthma and nausea, there are a bunch of the diseases author is explaining. First, asthma. There are some RCTs and systematic review. You think those are important. So based on these studies, he is claiming something like acupuncture is useful and acupuncture can be effective for asthma. In the same manner, he is telling the readers, acupuncture has some effect with nausea and vomiting. So all the ingredients are RCT and systematic review, but actually these ingredients had not been chosen in systematic way. So you can say this is analytic review, but not systematic review. So this is a narrative and analytic review. Can you see that? And third, descriptive and systematic. Descriptive and systematic. So this is a systematic search, but sources, ingredients are not RCTs. So let's see the example. Acupuncture-related cardiac complication, a systematic review. The title clearly saying it is a systematic review. But if you see this method, if you read it, there's no typical systematic review style method, but very simple. They use the mesh term, so it means they search the PubMed to find the adverse effect of acupuncture. So in this review, choosing RCTs is not the best option. So what you want to know and what you want to clarify, what you want to tell the readers is not the effectiveness of acupuncture, but reported side effect. In this case, limiting the resource ingredient into RCT is a stupid thing. That is not wise. You need to collect all the possible cases of adverse effect. In this case, cardiac complication. So you need all the ingredients, including descriptive studies, not only RCTs. And RCTs are usually not the best resource for clarifying or inform the side effect, because RCT is an experimental environment. So side effect in experimental environment can be different from real life. So this kind of descriptive study is more useful to clarify the adverse effect of something, not even acupuncture, but you can see many articles like this in adverse effect studies. So this is systematic but descriptive, not analytic. The resources are not RCTs. And this is the last one, analytic and systematic. And this is the typical systematic review, usually clinicians called systematic review. And this is at the top of the hierarchical evidence of hierarchy. So let's see, acupuncture for cancer pain in adults. So it does not say it is a systemic review in this title, but this is a topical systemic review, and this is from Cochrane Library. First, you can read this search method: Central, Medline, Embase. So those are major search engines. So if you read those search engines, find search engines in a search method, you can easily see this is a systematic review. So usually systematic review include more than 3 different major search engines to fit the purpose, fit the research topic. And there are exclusion and inclusion criteria. In this case, clearly letting the readers know what was the inclusion and exclusion criteria. This is the typical systematic review. Let me recap this quickly. So there are review study, and there can be different type of review study. First, you can divide the review study based on its resource. So when the review study is written based on analytic studies, it is called analytic review. And review study is written based on descriptive studies, like a case series or other descriptive studies. You can call that descriptive review. And second, based on search method, there is non-systematic review and there are systematic review. And systematic review, there can be a broad definition. As long as the search is systematic, you can call it systematic review. Usually in evidence-based medicine, we call that the systematic review only when its ingredients were RCTs. And these are the quadrant: descriptive and analytic, and narrative and systematic. This is the systematic review. Usually we call systematic review in EBM, but there are many different types of the reviews, including other type of systematic review. So here is the bottom line. There are many kind of review studies, and you can tell the purpose and the characteristic of the study based on this quadrant. Something is systematic. It is more suitable review study, clarifying the effectiveness of the certain intervention or the validation of diagnostic tool. And there are some studies with a written in descriptive manner, and those studies are useful for reporting or summarizing side effect, adverse effect of certain intervention. And there can be narrative studies, including descriptive and analytic, and these studies can be very informational. I hope you can understand review study better with this clip. So far, we studied type of studies and level of evidence. But what really matters is the ability you can discern level of evidence and type of studies in real practice with the real articles in journals. So we should practice with hypothetical cases, seems like cases a lot with these quizzes. Before we start quizzes, this is something we should prepare first. First, taxonomy flow chart. So two different flow chart, but basically they are same thing. Just the left one starts from experimental study and observational study. And right side one starts from descriptive study and analytic study. Just because these are properties, it is okay whether you start from left or right. This is the same thing. But in this class, I will use my own flowchart. What you need to do is asking each questions just one by one. Does it have a comparison group? Or is the comparison group assigned by force? And did this study start analysis from cause, exposure? So by answering these three questions, you can figure out what kind of study they are. So these three flowcharts are basically same. And second, we gotta prepare the pyramid of level of evidence. So I'd always find out one difference is this right one include animal study and in vitro study. And this is something I do not appreciate. So original EBM didn't consider these two studies as an evidence. So I would like to stick to this left side of pyramid. And this is the table I will use in this quiz for your practice. This table is adopted from Oxford CEBM level of evidence. First, systemic reviews of randomized controlled trial. And second, individual randomized controlled trial. And third, cohort study. And I put it all in this fourth level of evidence category, case control study, before-after studies, retrospective cohort studies. Because these studies are kind of arguable, some resources put this retrospective cohort study right under the cohort study. And before-after studies, if it is really qualified one, quality one, it can be a little bit upper. But I put everything here, fourth category, because in acupuncture field, most of the before and after study and retrospective cohort studies are not that high quality. Yes, it is true. And fifth, case series and case reports. Let's get started with the first quiz.
An investigation was carried out where a diverse group of adults were randomly split into two groups. The first group was directed to consume coffee daily for 6 months, while the second group was advised against consuming any form of coffee during the same period. Following this, the researchers examined the blood sugar levels and instances of diabetes among the members of both groups.
So in this case, what is the research question? So researchers trying to find out the correlation or causation between two factors. One is exposure, which is coffee intake. And what is the outcome? Diabetes mellitus. Then let's try to answer these three questions. First, does it have a comparison group? Take a look at this part. Randomly split into two groups. So there is a comparison group. There are comparison groups or comparison group. So yes, this is an analytic study. And is the comparison group assigned by force? Randomly split into, meaning researchers directed first some of the subject to consume coffee daily for 6 months. So this is a first full assignment. So this is experimental study, RCT or experimental study. By this description, randomly split into two groups, it can fall into randomized controlled trial category. So what is the level of evidence? So take a look at this. Individual randomized controlled trial. So number 2, second powerful evidence. Analytic study and experiment study. And also level 2 evidence. Next study.
To investigate the relationship between Alzheimer's disease and green tea consumption, we select 400 patients diagnosed with Alzheimer's within the past 5 years as the patient group. We select 400 individuals without Alzheimer's, matched for age, gender, and education level. Through interviews and dietary surveys, we collect data on green tea consumption patterns over the past 20 years and other related factors, lifestyle, genetic factors, etc. from both groups. We compare the frequency and amount of green tea consumption between the patient and control groups to determine if there is a significant association between green tea consumption and Alzheimer's disease risk.
So what is the research question of this study? Finding out correlation or causation between the two factors, green tea consumption and Alzheimer's disease. So green tea consumption is exposure and Alzheimer's is the outcome. And first question, does it have a comparison group? Yes, it does. Patient and control group. Somebody who have Alzheimer's and somebody who do not have Alzheimer's. So these are the comparison group. So this is analytic study. And is the comparison group assigned by force, meaning someone who got to be Alzheimer's, someone who are not supposed to be Alzheimer's. If the researchers decide that, we can say assigned by force. But take a look at this part. We select 400 patients already diagnosed with Alzheimer's within past 5 years. Who decided who get Alzheimer's? Nature, not the researcher. So this is a patient group and 400 individuals without Alzheimer's. Who decided that? Nature. So the right answer is no. So this is observational analytic study. Observational analytic study. Then last question, did the observational analytic study, this study, start analysis from cause? Where is the start point? They first divide into two groups. We usually call these two groups as a cohort. So one cohort with Alzheimer's, another cohort without Alzheimer's. So it started from outcome, consequence, Alzheimer's disease. So the answer is no. So this study is case control study. And case control study fall into the fourth category of the level of evidence. So right answer for this question is 4 in terms of level of evidence. Next question.
We recruit 8,000 healthy adults aged 50 and above and divide them into 3 groups based on green tea consumption frequency. The groups consist of 2,500 high consumers, 3+ cups daily, 3,000 moderate consumers, 3-5 cups weekly, and 2,500 low consumers, rarely drink. We monitor these 3 groups for Alzheimer's disease occurrence over 15 years. During the study period, we regularly record participants' green tea consumption patterns, cognitive function test results, and lifestyle changes. We analyze the effect of green tea consumption on Alzheimer's disease prevention by comparing incidence rates among the 3 groups.
So this study, similar, green tea consumption and Alzheimer's. And does it have a comparison group or groups? There are comparison groups. Groups who take green tea a lot, and second, moderate amount and low amount. So these are comparison groups. So does it have a comparison group? Yes. And is the comparison group assigned by force? So what does that mean by force? Researcher should assign some of the subject to drink green tea. Some of the subject drink green tea a lot. But this division assignment is done by just based on what they have been doing. So researcher didn't involve in green tea intake. So this one is, the right answer is no. And one thing you should be careful in this study is this one. What if the quiz says randomly recruit 8,000 people. Random. So it seems like a randomized controlled trial, but it is not. This random selection has nothing to do with random assignment. It is not a random assignment. This is random selection. So all this assignment is based on nature, what they have been doing. So it is just literal, mere observation. The next question. Did this study start analysis from cause? What is the cause and consequence? Cause is green tea consumption. Exposure. Alzheimer is outcome. So started from cause? Yes. So this is cohort study. All these different groups are called cohort. So level of evidence, number 3. Number 3, individual cohort study. What are the keywords here? Based on green tea consumption, they already have been doing. So this is not forceful assignment or random assignment. So this is observational study. And what is the cause and what is the consequence? Cause is green tea consumption and consequence, Alzheimer. So these are the cause, the exposure. So these are the keywords when you solve this question. Next question.
To investigate the relationship between multiple sclerosis and vitamin D deficiency, we target 300 individuals diagnosed with multiple sclerosis within the past year and 300 individuals without multiple sclerosis. We measure vitamin D levels through blood tests in both groups and collect data on related factors such as vitamin D intake and sun exposure time through surveys. We evaluate the association between vitamin D deficiency and multiple sclerosis risk by comparing vitamin D levels and deficiency prevalence between the patient and control groups.
So actually this patient and control group, meaning this is case control study. So very self-explanatory question. But let's see just one by one. Does it have a comparison group? Let's see. Multiple sclerosis and without multiple sclerosis. So this is a case group and this is control group. So two groups exist. So yes, analytic study. Is the comparison group assigned by force? No. Just based on nature, already diagnosed with MS or not. So this researchers didn't involved in this assignment. And third question. Is this group, these groups, sclerosis or not, multiple sclerosis or not, is it a cause or consequence? What is the cause? Cause is vitamin D levels. And MS is a consequence. So did it start from cause? No. Did it started from consequence, case and control. MS is a case, without MS is control. So level of evidence fall into fourth category. Case control study. Next question.
A research analyzed 200 individuals suffering from type 2 diabetes who enrolled in a 6-month lifestyle intervention program in the hospital. This program included dietary advice, exercise sessions, and stress management techniques. The data revealed an average reduction of 1.5% in HbA1c levels over the duration of the program. Researchers concluded that the lifestyle intervention program is effective in managing type 2 diabetes.
So what is the research question of this study? Research question is about program, special intervention program about the type 2 diabetes. So is it effective or not? That is a research question. And what is the conclusion? The intervention program was effective in managing to type 2 diabetes. So let's first answer our first question. Does it have a comparison group? No, there is no comparison group. So this is descriptive study. So this is before and after study. So they compared baseline data and after program, after management data, after intervention data. So 1.5% in HbA1c level decreasement was observed. But this is just descriptive study. So what happened with this program? They just describe what happened with this program. That's all with this study. So evidence level is quite low. So category 4. Next question.
We recruit 15,000 healthy adults and measure their serum vitamin D concentrations at baseline. We remeasure vitamin D concentrations every 5 years and check for multiple sclerosis diagnosis. We follow participants for 20 years, categorize them according to vitamin D concentration, and compare multiple sclerosis incidence rates for each category. We analyze the association between vitamin D concentration and multiple sclerosis risk.
Yes, this study type is a little bit unique because the cause exposure is changing every year, every 5 years. But nothing is different. Just follow the steps. First, does it have a comparison group? Yes, it does. Vitamin D concentration. Every 5 years. So they will probably categorize them into low concentration or high concentration or middle concentration. That is not clarified in this description, but there is a comparison group. So this is an analytic study. And this comparison group was assigned by force, likewise randomization, random assignment. No, this the exposure, not outcome exposure, vitamin D concentration is totally based on patient lifestyle. So nature designed it, not the researchers. So this is observational study. And what is the start point? Did this start from the cause or consequence? What is the research question of this study? Vitamin D concentration affect MS incidence. So vitamin D concentration is exposure cause and MS is outcome consequence. So start point was dividing groups based on vitamin D concentration. So it started from cause. So this is cohort study. Evidence level, category 3. Next question.
To investigate the relationship between atrial fibrillation and caffeine intake, we select 500 newly diagnosed atrial fibrillation patients within the past 6 months and 500 individuals without atrial fibrillation. Through surveys, we collect data on daily caffeine intake, coffee, tea, carbonated beverages, etc., and related factors, alcohol intake, stress levels, etc., from both groups. We evaluate the association between caffeine intake and atrial fibrillation risk by comparing caffeine consumption to groups.
So obviously, this study has groups, 2 groups, so analytic study. And what is the research question? Association between coffee intake and atrial fibrillation. And this comparison group was divided by force, likewise randomization? No. It started from someone who has atrial fibrillation and someone who do not have atrial fibrillation. So this is case and this is control. So nature decided, so observational study, among observational study, it is case control study. It started from outcome, who have certain disease and who do not have certain disease. This is outcome. not the exposure. And it goes reverse. So from the outcome, they try to trace their daily caffeine intake. This is a cause exposure. So this is case control study. In terms of evidence level, it has quite low level of evidence. Fourth category, under cohort study. If you want to make it a cohort study, you need to divide the group based on caffeine intake. And later, likewise 6 months later, 10 months later, or 10 years later, you got to compare incidence of atrial fibrillation. That will make cohort study better study in terms of level of evidence. Next question.
We recruit 10,000 adults aged 40 and above without cardiovascular risk factors and assess caffeine intake through dietary surveys at baseline. We repeat surveys every 2 years and confirm new atrial fibrillation occurrences through ECG tests and medical records. We follow participants for 12 years, categorize them by caffeine intake, and compare atrial fibrillation incidence rates across categories. We analyze the association between caffeine intake and atrial fibrillation risk using Cox proportional hazards models, adjusting for potential confounding variables including age, gender, body mass index, hypertension, diabetes, smoking, and alcohol intake.
So what do you think? What is the research question? It's very similar to later study, right? Late study. It's about caffeine intake and incidence of cardiovascular disease. So this is analytic study with a comparison group. And the question is this observational study or experimental study? Who decided who take caffeine a lot and who take caffeine less? Nobody did. So it is based on their daily living, their lifestyle. So observational study. Then did it start from cause or consequence? So they started from here, dividing the groups by caffeine intake. So is this cause or consequence? Caffeine intake is a cause of cardiovascular risk. So it started from cause. So this is cohort study. So evidence level, category 3. Next question.
To investigate the relationship between anxiety disorder and meditation practice, we select 350 individuals diagnosed with anxiety disorder within the past 2 years and 350 without anxiety disorder. Through interviews and surveys, we collect data on meditation practice history over the past 10 years and other related factors, stress levels, life events, etc. from both groups. We determine if there is a significant association between meditation practice and anxiety disorder risk by comparing the prevalence of meditation practice history between two groups.
Okay, does it have a comparison group? Yes. What kind of comparison group? Someone who have anxiety disorder and someone who do not have anxiety disorder. So this is a case group and this is control group. So this one is easy. So case control study. So nobody decided who get the anxiety and who do not get the anxiety. Nature did, God did, and they did. So this is observation study, analytic study, and case control study. Evidence level, category 4. Next question.
To investigate the relationship between inflammatory bowel disease, IBD, and probiotics intake, we select 250 patients diagnosed with IBD within the past 3 years and 250 individuals without IBD. Through interviews and dietary surveys, we collect data on probiotic intake history, dairy products, supplements, etc. over the past 5 years and other related factors, dietary habits, antibiotic use history, etc. from both groups. We determine if there is a significant association between probiotics intake and IBD risk by comparing probiotic consumption patterns between two groups.
Yes, this is a research question. Very straightforward. Probiotics intake and IBD. So is there a comparison group? Yes, there is. Patient with IBD, patient without IBD. So this is case and this is control. So this is case control study. Researchers cannot force someone have IBD and someone don't have IBD. That is not possible. So this is observational study. And these numbers, subject numbers, all these examples has the same numbers, but not necessarily. You can recruit same number of subject, that is possible, but in terms of prospective study like cohort study, there are many dropouts. They just abandon the study. So these numbers will be different. In terms of experiment study, it is really hard to make the even numbers. Of course, there is dropout patient, subject, and also sometimes it is very hard to recruit the patient with certain diseases. So not necessarily these numbers have to be equal. Next study.
We recruit 10,000 healthy adults and divide them into 3 groups based on probiotics intake level. The groups consist of 3,000 high consumers, daily intake, 4,000 moderate consumers, 2-3 times weekly intake, and 3,000 low consumers, rarely consume. We monitor these 3 groups for inflammatory bowel disease occurrence over 8 years. During the study period, we regularly record participants' probiotics intake patterns, gut health status, and dietary habit changes. We analyze the effect of probiotics intake on IBD prevention by comparing IBD incidence rates among the 3 groups.
So what is the research question? Actually, same research question. Association between IBD and probiotics intake. But a little bit different study. First, does it have a comparison group? Yes, it has a comparison group. And this comparison group assigned by force, by God, or researchers. So let's take a look at this part. The group consists of 3,000 high consumers and 4,000 moderate consumers and 3,000 low consumers. So who decide that? Who decide who will be in high consumer group or who will be in low consumer group? Nobody decided. So nature just decided it. So it is observation based on subject lifestyle. So this is observational study, not experimental study. And the last question, did this study started from cause or consequence? So what is this? Is this cause, the probiotics consumption? What is the research question? Probiotics intake and IBD. So IBD is a consequence and probiotics intake is a cause. So it started from cause by dividing groups in terms of exposure. So that makes cohort study. So this is a very powerful study in terms of evidence level. Category number 3. Next quiz is a little bit more complicated.
Acupuncture may help prevent rheumatoid arthritis. According to a recently published study, people diagnosed with rheumatoid arthritis were found to have significantly lower rates of regular acupuncture treatment compared to those without the condition. This suggests that acupuncture may play a positive role in preventing rheumatoid arthritis. The research team studied acupuncture treatment history in 500 people diagnosed with rheumatoid arthritis over the past 5 years and 500 people without the condition. Both groups had similar key characteristics including age, gender, and lifestyle habits. The study found that the group diagnosed with rheumatoid arthritis had approximately 30% lower rates of regular acupuncture treatment. Experts noted that acupuncture may help regulate immune function and reduce inflammation, while adding that additional research is needed to clearly establish the causal relationship between acupuncture and its preventive effects on rheumatoid arthritis. They also emphasized that it's important to choose appropriate treatment methods considering individual conditions.
So in this case, does it have a comparison group? Yes, it has a comparison group. What kind of comparison group? The patient, 500 patient with arthritis and 500 patient without arthritis. This number can be different. It doesn't matter. And is the comparison group assigned by force? Nobody forced someone who has arthritis or not. So nature decided. So this is observational study. And what is the third point? Did it start from the cause or did it start from the consequence? So what is the cause and consequence? What is the research question? Causal relationship between acupuncture and its preventive effect on rheumatoid arthritis. This is a research question. But if you really want to prove causal relationship, causality, this observational study is not enough. You need an experimental study. But anyway, this study is a research question. So what is the correlation between acupuncture and rheumatoid arthritis? Acupuncture is the cause and rheumatoid arthritis is a consequence. And this study started from patient with arthritis or not. In other words, case and control. So this is case control study. Evidence level is quite low for it. And this is very hypothetical study. We do not conduct this kind of study with acupuncture. So instead of acupuncture, maybe touch practice can be a better variable for this kind of study. Next one.
The study included 2,000 healthy adults, divided into two groups. One group of 1,000 individuals who regularly consumed red ginseng, and another group of 1,000 individuals who did not. At the beginning of the study, both groups had similar immune status, and key characteristics such as age, gender, and lifestyle were matched. The study lasted for 3 years, during which researchers regularly monitored the incidence of colds and immune-related indicators in both groups. After 3 years, only an average of 10% of the group that regularly consumed red ginseng caught colds annually, compared to 25% in the group that did not consume red ginseng. Additionally, the red ginseng group showed positive changes in immune-related blood markers. These results suggest that regular consumption of red ginseng may have a positive effect on cold prevention and immune enhancement. The researchers concluded red ginseng contains antioxidants and immune-regulating components that may help strengthen the immune system and prevent minor infectious diseases such as colds when consumed regularly.
So what is the research question of this study? Regular intake of ginseng and immune system. So that is the research question. And I think this is a very fair conclusion they made. So ginseng intake may help strengthen immune system. So this is not that strong, and it claims correlation between those two factors. And what is the cause exposure in this study? Ginseng intake is a cause. And what is the consequence, outcome? The infections, minor infections, the changes of immune system, those are the outcomes. So does it has a comparison group? Yes, it does. Two groups. One group take ginseng regularly, another group do not take ginseng regularly. So this is analytic study, not descriptive study. And is a comparison group assigned by force? Did the researcher force some of the subject to take ginseng or another group of subject not to take the ginseng? That will make experiment. But they didn't. They just researched what they have been doing, and they divide them into two groups based on their habit they already have been doing. So this is observational study. Nobody forced them. And what is the start point? This is the start point. One group takes ginseng, another group does not take ginseng. What is ginseng? It's an exposure. So it started from cause and exposure. And later they compared incidence of common cold and blood markers. So this is cohort study. So number 3, evidence level. So right below the RCT. Next.
According to a recent study, people suffering from chronic insomnia were found to have significantly lower rates of regular aromatherapy use compared to those without insomnia. This suggests that aromatherapy may help alleviate insomnia. The researchers compared aromatherapy usage history between 300 people who reported chronic insomnia for 6 or more months and 300 people with good sleep quality. Both groups had similar key characteristics, including age and gender. The study found that the chronic insomnia group had approximately 40% lower rates of regular aromatherapy use. An aromatherapy expert explained that certain essential oils can help improve sleep quality by calming the nervous system and reducing stress. However, they advised that since effects can vary by individual, it's recommended to consult with an expert to find the most suitable method.
And this is kind of a common press report you can find in a newspaper. So what is the research question? Aromatherapy and insomnia. So is there any correlation or causation? That is a research question. And what is the conclusion? Certain oil can help improve sleep quality. So this is conclusion they made. Then let's see how strong evidence it is. Does it have a comparison group? Yes, they do. So what is the comparison group? 300 people with insomnia. Another 300 people without insomnia. So comparison group, analytic study. And these two groups, are they divided by force? No. So this is observational study. And what is the start point? Somebody who have insomnia, somebody who doesn't. So this is case and this is control. So case control study. It started from consequence. Aromatherapy is the cause. But they didn't divide two groups based on aromatherapy uses, but they divided into two groups based on consequence, which is insomnia. So this is case control study. Evidence level 4th. Next quiz.
Study title: The Impact of Zero Sugar Products on Body Weight and Obesity Prevalence. Sample selection and grouping. A diverse group of adults is randomly selected. These participants are then randomly assigned to one of two groups: the experimental group and the control group. Intervention: participants in the experimental group are instructed to replace their normal sugar consumption with zero sugar products for a year. Meanwhile, the control group continues their regular dietary habits without specifically incorporating zero sugar products. Monitoring and data collection. Throughout the study, the participants' diets, physical activity levels, and other relevant lifestyle factors are regularly monitored and recorded to ensure consistency and account for potential confounding variables. The participants' body weight and body mass index, BMI, are measured at the beginning of the study, then periodically throughout the year, and again at the end of the year. Data analysis. At the end of the study, researchers compared the changes in body weight and the incidence of obesity in both groups. They also adjust the results for other variables like physical activity level and total calorie intake.
So in this study, we got to think about what is the research question first. What is the research question? Research question is usually reflected on its title. So impact zero sugar products and body weight and obesity. So they want to find out the relationship between these two factors. And this is the outcome: body weight and obesity. And zero sugar product is the exposure or the cause. So this is independent variable, and these are dependent variable. So there are many different ways of describing these two factors. So does it has a comparison group? Does it? Yes, it does. Zero sugar product group and the group who do not alter those dietary habits. So just regular diet without specifically incorporating zero sugar product. So there are two groups. So this is an analytic study. Then the group was divided with a force by force. Please take a look at this specific term, randomly assigned. These two groups, zero sugar or just regular diet, they were randomly assigned. That means no matter how much you want to be in the group with zero sugar, it is not possible you can decide. Everything is decided by random assignment. So this is random assigned randomized controlled trial. So this is experiment. Evidence level, second high evidence level. So this is randomized controlled trial. Next one. This is about Japanese herbal product named Jumihai Dokuto. And let's see how they conducted this study.
Palmoplantar pustulosis, PPP, is a chronic skin disease characterized by sterile intraepidermal pustules associated with erythematous scaling on the palms and soles. Jumihei Dokuto is a traditional herbal medicine composed of 10 medical plants and has been given to patients with suppurative skin disease in Japan. This study investigated the effect of Jumihei Dokuto on the disease activity in PPP patients. N equals 10. PPP patients were given Jumihei Dokuto, EKT6, 6.0 grams per day, for 4 to 8 weeks in addition to their prescribed medications. The results showed that the palmoplantar pustular psoriasis area and severity index PASI was decreased after the administration of Jumihei Dokuto, P 0.05. Therefore, Jumihei Dokuto is seemingly effective against PPP.
So does this study have a comparison group? I'm afraid not. There's no comparison group. Then what is this address? Statistical significance. P-value is under 0.05. This is the statistical difference, significance between before and after. So this is before and after study. So this is descriptive study and before and after study. It falls into fourth category in terms of evidence level. So quite low because it doesn't have a comparison group. Without this medication, patient can get better with many different factors like seasonal changes, climate changes, or just by the fact they involved in this study can make a difference. Next study.
Acupuncture versus cognitive behavioral therapy for insomnia in cancer survivors. This trial compared 8 weeks of acupuncture, N equals 80, and CBTI, N equals 80, in cancer survivors. We randomly divided selected 160 subjects into 2 groups. Acupuncture involved stimulating specific points on the body with needles. CBTI included sleep restriction, stimulus control, cognitive restructuring, relaxation training, and education. We measured insomnia severity, primary outcome, pain, fatigue, mood, and quality of life post-treatment, 8 weeks, with follow-up until 20 weeks. We used linear mixed effects models for analyses. The mean age was 61.5 years and 56.9% were women. CBTI was more effective than acupuncture post-treatment, P 0.001. However, both acupuncture and CBTI produced clinically meaningful reductions in insomnia severity.
Okay, so does it have a comparison group? Yes, it does. Acupuncture versus CBT. So it is a comparison group. They are comparison group. So acupuncture was compared to with CBT. So this is called active control. So there's no placebo control, there's no treatment control, but both are active control. In this case, we are comparing the efficacy between these two factors, acupuncture and CBT. And CBT's effectiveness is well known in the society, so if the acupuncture has at least equal efficacy or higher efficacy than CBT, we can conclude acupuncture has a meaningful effectiveness. So it has a comparison group, so this is an analytic study. Then, is this comparison group assigned by force? We randomly selected 160 subjects, right? So that means there was a force. So people who need to get an acupuncture regardless of their favor or their intention just dies. Coin decided everything. So this is RCT and experimental study. So this is a very powerful study. And what is the fair conclusion? So you should not be confused with drawing the right conclusion. So what is the research question of this study? Acupuncture and cognitive behavioral therapy has a equal or different efficacy. That is a research question. Which one is better and which one is worse? And it says, this is a conclusion, CBT was more effective than acupuncture. P-value 0.001. So statistically, we can say CBT is better than acupuncture in terms of managing insomnia. However, both acupuncture and CBT produced clinically meaningful reduction in insomnia severity. And what does that mean? This is actually not intended result. So primary research question was the comparison between these two factors, acupuncture and cognitive behavioral therapy, and how they drew this kind of conclusion based on before and after study. So before and after, by comparing before and after, they could draw acupuncture was effective and also CBT was effective. So this is not a meaningful conclusion. Because it is just based on before and after study. So this was not the purpose of this study. Comparison between these two factors, acupuncture and CBT, that was the research question. So fair and primary conclusion is CBT was more effective than acupuncture. In terms of this conclusion, evidence level is very high, number 2. But in terms of this conclusion, both were effective, evidence level 4. And let's take a look at this part. Acupuncture was more effective for pain at the end of the treatment. Both groups have similar improvement in fatigue. So in terms of this pain, acupuncture has a higher efficacy than CBT. So this conclusion is based on RCT. So evidence level number 2. Next question.
9 patients with diabetic neuropathic pain were recruited from a Korean diabetic clinic and given 12 sessions of acupuncture over 4 weeks. Their symptoms were evaluated using the Total Symptom Score, TSS, and Michigan Neuropathy Screening Instrument, MNSI, at baseline and 4 weeks after the last treatment.
Okay, so does it have a comparison group? No, it doesn't. So this is descriptive study. And how did they get this kind of result? Baseline and 8-week follow-up. And what does that mean? They compared before baseline and after 8-week follow-up. So actually the treatment was 4 weeks. So 4 week and 8 week, those data collected at those time were compared. So this is descriptive study. In terms of evidence level, it falls into 4th evidence level category. So not that meaningful result in terms of evidence. And this is quite interesting study.
1 drink a day is beneficial is an outdated notion. It increases cancer mortality. Even light drinking is harmful to health and may increase cancer mortality in older adults, according to a recent study. While the belief that a drink a day is good for your health persists, this research highlights the risks associated with even moderate alcohol consumption. A research team from the Autonomous University of Madrid in Spain tracked alcohol consumption and mortality rates over 12 years in 135,104 individuals aged 60 and older, registered with the UK Biobank. Participants were categorized into 4 groups based on their daily alcohol intake: lowest risk, low risk, moderate risk, and high risk. The low risk group consumed up to 2.86 grams of alcohol daily, roughly equivalent to a quarter glass of wine. The high risk group consumed around 40 grams of alcohol daily for men, comparable to 2 pints of beer. The researchers analyzed the risk of death from cancer, cardiovascular diseases, or any cause. The results revealed that the high-risk group had a 33% higher all-cause mortality risk compared to the lowest-risk group. Their risk of dying from cancer or cardiovascular diseases was also significantly higher. The moderate-risk group had a 10% higher all-cause mortality risk and a 15% higher risk of dying from cancer or cardiovascular diseases compared to the lowest-risk group. Even the low-risk group faced an 11% higher risk of cancer or cardiovascular-related death than the lowest-risk group. Additional findings show that individuals in the lowest or low-risk groups with relatively low socioeconomic status experience worse health outcomes. The research team noted that older adults in poor health are more likely to take medications that interact with alcohol and may have lower alcohol tolerance, making them more vulnerable to its effects. Professor Rosario Ordozer, the study's lead author, emphasized even a single drink increases the risks of cancer and death, so alcohol should not be recommended for health reasons. This study was recently published in JAMA Network Open.
So it's quite interesting study. So let's try to answer in the same manner. So does it have a comparison group? How about this study? Yes, it does. What is the comparison group? Low risk, lowest risk, low risk, moderate risk, and high risk alcohol consumption. So there are 4 different groups. And first, what is the research question? Is there any correlation between alcohol intake and cancer mortality, right? Cancer mortality. So we want to find out the correlation between those 2 factors. Cancer mortality is outcome, consequence, and alcohol intake is cause and exposure. So this is an analytic study. There is a comparison group. And these groups, what do you think? Were divided by God or researchers? Researchers played God instead of God? Did they? Was there random assignment? No. This categorization is totally based on subject, daily living, their habits, their lifestyle. So this is not something researcher made decision. This is something actually nature made. So this is observational study, not experimental study. Observational study. And how about the third question we got to ask? Did this study started from cause or outcome? So this is the start point by dividing subject into 4 different groups. And after that, 12 years, it took a lot of time, 12 years, and they analyzed data with cancer mortality. So it started from cause and outcome was compared later, 12 years later. So this is cohort study. Exposure to outcome. So this study has a quite strong evidence level. Number 3, among observational study, this is the best study we can conduct. So in summary, this study is analytic study first, and observational study second, and cohort study in observational study, and evidence level third category. So let's summarize it again. These are the comparison group and how they divided by their daily living, how they lived. And this is not random assignment. And what was the start point? They divided into 4 different groups and they analyzed risk of death of cancer. So this is typical cohort study. Okay, that's it for today's practice. And make sure to review the class material. And please remember the most important thing about this practice is reading actual articles and actual abstract of published journals. So when you think about level of evidence when you read those articles and newspapers, it will be really helpful if you understand, analyze the level of evidence. That will help your practice for better decision making. Okay, I hope you enjoyed the class and see you next week. Take care.